Can we see the screen? Okay, thank you. All right, so we're going to finish up what we were doing last time, and then we'll start something new here. So we were talking about key features of a quadratic equation. So one of the things we discovered that the quadratic equation has a U shape. And we'll just do a quick review on that. Let's maybe bring the Desmos up. That would help. All right, so we'll take a look at Desmos for a couple minutes, and then we'll move on. All right, so just to remind ourselves here. So we've got x. So you see y equals x, that's just a line. But then x squared, we get that U shape. Okay. So what we discovered so far was that we have this point here called the vertex. We're going to talk about that a little bit later today. And this is either the lowest point or the highest point, depending on what's going on. So what we discovered was that if we put a number in front of our x squared, that things happen as far as the, I guess, the width of our parabola. And that's what that U-shaped thing is called. It's called a parabola. They like fancy names for everything, as you know. Okay. So if we put a number in front of this, if the number is bigger than 1, say 5, notice how our parabola got skinny. Because the 5 means it's going up 5 times as fast. So in this one here, we start at 0. If we go over 1, 1 times 1 is 1, so that's right there. But in this one, we go over 1, 1 times 1 is 1, but then we multiply it by 5, so we come all the way up to here. So that's why it looks like it's skinnier, because it's going up faster. Okay. Then we also discovered that if we put some sort of decimal number in front of it, it's a little bit flatter or wider. So let's take a look at one of those. Okay, so if we put a number in front of here, like maybe 0.1. So what that means is it's not going up nearly as fast. So when you have a decimal out front, that means you're going to be going up slower, which means that your parabola is going to look wider. Okay, so that was some of the stuff we were talking about yesterday. Then one other thing, of course, is that if you put a negative sign in front of any of these, it's going to flip it over. So this will be the red one here. I'll put a minus sign in there, flips it over. Let's get this guy out of the way so we can see it. There we go. So it just flips it the other direction. Now this vertex point at 0, 0 is actually a maximum value. This is the top of the roller coaster here, where when it's going the other direction, such as here, that 0, 0 is the bottom. Okay, and then any of these guys, like I say, you can just flip them over by putting a negative sign. Oops, I just put a 1 in front of it instead of a negative sign. Here we go. All right, so you get the idea. So bigger number makes it skinnier. Decimal number, like between 0 and 1, makes it wider, and then a negative flips it around the other direction. So that's pretty much where we're at with this thing so far. Okay, any questions on that? That's a quick review of yesterday. All right, so let's go ahead and wrap up. I think we have just a couple quick questions here at the end, and then we'll move on to what's known as vertex form. We'll talk about that a little bit. All right, so we'll say goodbye to Desmos for right now. All right, so we did all this good stuff yesterday. So we're just left with these couple guys. All right. So this is kind of like a problem you might see on the Algebra 1 EOC. So it says the total cost in dollars of a square carpet can be determined by f of x equals 15 times x squared, where x is the side length in yards. It says select all the true statements. So what this is telling us is it sort of has a base price of 15 bucks, and depending on how big your carpet is, you're going to multiply it by some number. Okay, so it says the cost of the carpet increases and then decreases as the side length increases. Well, that's not true, because it's just going to keep increasing, right? Anytime you have something and you square it, you're always going to get a positive value. Okay, so that guy's not right. All right, how about the next one here? The cost of the carpet is $15 per square yard. Yeah, that's probably pretty good, because if you start off and it's just 1 by 1, you have 1 square yard, and 1 times 1 is just 1 times 15 is 15 bucks. Now, if you have 2 by 2, then you have 2 times 2 is 4, and 4, so you'd have 4 square yards, and then it would be $15 for each square yard, which would make it 60. So that guy's good. We'll take that one. So yeah, we like this guy. He's good. All right. That's a nice looking check mark, if I do say so myself. It says the cost of the carpet with a side length of 3 is $135. Okay. So we'll get our calculator out for that one. Bring him in here. I'm trying to bring him in here anyway. There we go. All right, so we got 15x squared, and x now equals 3. So let's clear this out. So we got 3 squared, so that's 9. And we take that times 15. So yeah, equals 135. So that one's good too. All right. So next one says the cost of a carpet with 6-yard sides is twice the cost of the carpet with 3-yard sides. All right, so that's telling us that if it's twice the cost of the 3-yard side, we just figured out that's 135. So let's check it out. So if it was twice the cost, we would just say, okay, we're going to multiply by 2, and we get 270. So the question is, will we get 270 using the other equation? So the other equation was that we're going to do the side length is 6, so that's x. Then we square x, and then we take that times 15. That's 540. So it's not the same, is it? So the reason for that is if it was twice the price, it would be twice the length here. Well, 3 times 3 is going to be 9 square yards. So if you had another carpet just like it, that would be 18 square yards, right? So you have one 3 by 3, and you have one right next to it 3 by 3. So I give you 18 square yards. This guy is 6 square yards each, so it's 6 square yards one way, 6 square yards the other way. Okay, so that 6 times 6 is 36, and then times the 15. So it's actually double the cost. But 6 times 6 is 36 square yards, where the other one, you would have 3 times 3 and double that, so that would be 9 times 2 is 18. So that one's not right. So the last one says the cost of the carpet increases at a constant rate as the length increases. Okay, that guy's not right either, because what it increases by is if you have a 1 by 1, that's 1, right? 2 by 2 is 4, and 3 by 3 is 9 yards, 9 square yards. Okay, so that's not a constant rate. A constant rate is linear. Okay, so if it was 15x, yes, that would be true. But since it's 15x squared, it is not. Okay, so that's what's going on with that guy. So it's just B and C for this particular one. Okay. Any questions? All good? All right. All right, so we just got an SAT question yet, like an SAT style question, I guess I should say. Then we'll move on to the next part. Okay. So it says the graph of ax squared opens downward and is narrower than the graph of the quadratic parent function. So which of the following could be the value of a? All right, so if it opens downward, do we need a positive value or a negative value? It's going to open downward. Should it be positive or negative? Yeah, minus. So the good news there is the fact that we know, since it says it opens downward, we know that it has to be a negative value, so that makes these three guys wrong. Cool. So now the question is, it says, and is narrower. Narrower means skinnier, right? So would that happen with the -2 or would that happen with the -0.5? So what's our answer going to be, A or B? Yeah, it's going to be the 2, which is A, right? Good. So if it's narrower, it has to be a number bigger than 1. And since it's downward, it has to be negative. So that's our guy. If they'd have said wider, then it would have been B. Okay, good. Okay, so that wraps that up. We'll get this guy out of the way here. Move on to our new stuff. All right, so our next topic, topic 8.2, is something called quadratic functions in vertex form. Now, I've mentioned the vertex already, haven't I? So the vertex is, we have a quadratic graph or a parabola, this U shape, right? The vertex is either the lowest point or a minimum, or if it goes this way, it's the highest point or a maximum. Okay, so the vertex could be this guy or it could be this guy. Okay, so here's what we're going to find out about these guys. I just popped up an extra screen so we can talk about it a little bit. So one of the things they talked about with these guys is, so if we have this, right, and we have this vertex here, right, if we drew a straight line up through the vertex, and of course if I drew a little better, probably, maybe I should use the Desmos for this, but this will be okay for right now. So if I draw a straight line up through this thing, right, what this does is it divides our parabola, or our U shape, into two basically equal looking pieces, except one is a mirror image of the other. So the green dotted line here is almost like a mirror, and it turns this thing into two pieces that pretty much look the same, except they're reflected around that piece, right? So of course they got some names for this stuff. So we already know that this guy is the vertex. Okay, and then this guy, you know, the math guys have to have fancy names for everything. So this guy is called the axis of symmetry. Okay, so the axis of symmetry, again, divides it into two symmetrical pieces. They pretty much look the same, except they're mirror images of each other. Now, if our vertex here was at 0, 0, right? Which they have been so far, all of them have been met, okay? Then your axis of symmetry is x equals 0. So it's just the first guy in this ordered pair. Whatever number that is, x equals that. Because x equals, excuse me, x equals some number is just a vertical line, a line going up straight up and down. So x equals 0 is actually the equation of this line as well. Okay? So when they say vertex form, what they're looking for is they'll look for something either called y or f of x, because those are the same thing, okay, is going to equal x plus some number. So we don't know what the number is yet, okay? They call that h for some reason. So x plus h, and then that's going to be, the whole thing's going to be squared, and then plus just some other constant number like this. So this is actually vertex form right here. So that's what that is. Okay. So the way this works, and hang on, I got something messed up here. Just a second, let me fix this, because this is kind of important. This guy is actually minus. Okay, that's vertex form. My bad. Okay, so the reason for this is, in this case, if we have 0, 0, that means this is our h value is 0 and our k value is 0. So then this guy would be y equals x minus 0 squared plus 0. Now, of course, the lazy math guys aren't going to write it that way. X minus 0 is still just x, so this is just going to be y equals x squared, and they're not going to write plus 0. So that's your guy. And that's your basic parent function there, because it starts at 0, 0. Okay? Now, it could have a number out front, like we've seen, right? So we could have a number here, and I probably didn't leave enough room. We could call that a. So a in this case is 1, right? But it could be something else, like we were looking at, that one was like 5x, or it could be 0.1x or something like that. So you are going to have a number out front. So this is your final version of vertex form right here. Okay. And then what that does is, if you had, say, another parabola, let's say this one had a vertex of 2, 5. Okay. So we're just going to assume that a equals 1. They didn't tell us that, right? So they're just going to leave it like that. So then this would be y equals a, which is just 1, so we're not going to write that. That'd be x minus 2 squared, and then plus 5. Now, the cool part about this is, if they say to you, here's an equation of a parabola, right? And they say, well, what's the vertex of this guy? Well, this is in vertex form. And the reason it's in vertex form is it's really easy to tell them what the vertex is. And here's all you have to do to figure out the vertex. The vertex is going to be an xy point, like right here, or right here. Okay? So to tell somebody what the vertex is, what we do is we switch the sign on this guy, so he becomes plus 2, and we leave this guy alone. Just bring him down. 2, 5. There's our boy. So if they give you vertex form and ask you for the vertex, it's real easy. Switch the sign on the guy with the x, leave the other guy alone, and that's your vertex. So that's either your high or low point, depending on whether this number out front is positive or negative. Does that make sense? So this is just one way you can write a parabola or an x squared. Okay, so that's pretty easy, right? Okay, so it's just a little background information, and then we'll use this to do some of the problems here. So let's go ahead and have a look at those. All right, so this says identify the vertex and the axis of symmetry for each function. Okay, so for the first guy here, technically this is, I'm going to write it over here. This is f of x equals x minus 0 squared. Now the lazy math guys are going to put that in there, but we're going to put it back in for a reason. Plus 2. All right, so they want to know the vertex, right? Well, we can figure that out. It's vertex form, right? So we switch the sign on the first guy. Well, minus 0 is plus 0. It's still 0, right? So it's going to be 0. And then this guy is just going to be 2. Okay. So that's the vertex. The axis of symmetry, this is easy. The axis of symmetry is always this guy. X equals this guy. So your axis of symmetry is x equals 0. That's it. Easy and peasy. So 16 is kind of the same thing, right? So for 16, what's our vertex on this guy? Zero and minus 5, right? So we have the 0, and we just leave this guy alone, so he's negative 5, okay? And then once again, our axis of symmetry is just the first guy, so x equals 0. That's not so bad. So 17, what's our vertex here? Yeah, 0 minus 1. And then once again, our axis of symmetry is going to be x equals 0. It's always the first guy. And how about the last one? Yep, so 0 and 0.5. And then once again, x equals 0. So what's going on here is notice that the x squareds are all just x squared, so it's all zeros, right? The only difference is these guys changed. Okay. So let's bring our good friend Desmos back in for a second. We can use some of the guys we've got here. All right, so let's go ahead and we'll switch these guys back. All right. I got them all x squareds, right? So the first guy was x squared plus 2. So remember when we talked about functions before, that if you just tack a number on, like plus 2, your graph is going to move straight up 2 units, right? So we go plus 2, there it is. The next guy was minus 5, wasn't it? That means he's going to move down 5 units. Minus 5. And again, here's our vertex. Remember we said our vertex was 0 minus 5. And our vertex on this guy is 0 minus 2. And again, your axis of symmetry on all these guys is x equals the plus sign, x equals 0. So you see that purple line divides each of our parabolas into mirror image pieces, right? So the axis of symmetry is always just the first value of the vertex. So as you can see right here, first value of the vertex is 0. X equals 0 is this guy running up through the middle here. All right. Pretty easy so far. All right, so we might come back to Desmos. Let's pull him out for a sec. Okay, so this is more of the same, right? So the first two are easy. We know how to do that, right? So 22 is where it gets a little weird, right? So let's do the rest of them real quick here. So this one here, again, we've got 0, right? And minus 0.225. This one here, we're going to have 0 and 7. This one here, we're going to have 0 and 50. And all three of them, the axis of symmetry is x equals 0, right? For that one, and that one. All three are x equals 0, right? So 22 is where things get a little weird, right? So let's rewrite 22. So we got 22 here is g of x equals x minus 1 squared. And we don't have a number outside, do we? Like we do here, here, and here. So just for now, till we get used to it, we're going to say plus 0. Okay. So what's our vertex of this guy? Remembering the way that we do this is we change the sign on the guy that's with the x, and we leave the other guy alone. So what's our vertex here? Yeah, good. So our vertex here is going to be 1, 0. So what's our axis of symmetry for this guy going to be? What is x going to equal this time? Up here it all equaled 0, right? So what's x going to equal here? Boom. Perfect. Nice job. Okay, so let's bring back the Des. All right, so we're not going to need this guy or this guy or this guy for right now. So we need this guy. So let's go ahead and put some parentheses around this guy. All right. That. And then we have to do minus 1, right? So I moved it over. Let me put the original in here just to keep things looking good. All right, so by having x minus 1, here is our vertex, right? 1, 0, just as we predicted. And then your axis of symmetry for this guy will be x equals 1. There it is. Okay. So, and we've talked about this with what they call transformations before, that when you have a number in with the x, like we do here, it moves kind of the opposite of what you think. You see minus 1, you think maybe we're going to the left, but we don't. We go to the right. Because it's really asking what number do I put in here that makes this 0. So if I have x equals 1, as I do here, then I have 1 minus 1 is 0. And 0 squared is still 0. That's why we're sitting right there. Okay. So far we've seen vertex form where we moved it up and down. Now we've seen one where we moved to the right. And obviously if we put a positive number in here, we would move to the left. Let's do that real quick. Now we're over here. So now we're over here at minus 1, 0. And then that would also mean that your axis of symmetry would be x equals minus 1. Okay. All right, so we're moving along here. So these guys are going to be more than the same, right? So what's our axis of symmetry for this guy? For number 23. It always does, right? Okay, so minus 2 and what? You're right about the minus 2. What's the other part going to be? Well, remember the bit like in the last one? Let's go back here for a second. So, no, that's not it. This one. We wrote it as x minus 1 squared plus 0. So don't we kind of have to do the same thing here? So what's our second number going to be? Yeah. And then your axis of symmetry for this guy is just x equals the first number. So x equals minus 2. Beautiful. All right, so 24. What's our vertex on this guy? Yeah, 6, 0. I don't know what happened there. Let's fix that up. Let's change colors too, why not? So this will be 6 and 0. Good. And then x equals 6. Perfect. Somebody's onto this thing. All right, so the rest is easy, right? So this guy is going to be 0.5 and 0. And then x equals 0.5. And then finally we've got 4 and 0. Right, just switch the sign. And if there's no number here, it's automatically 0. And then our axis of symmetry is x equals 4. Bam. Moving and or grooving. Good. Questions? Let's take a look at one more and we'll call it. Well, actually, one more which has 2 on it. There we go. So it says write each function in vertex form. Okay. So for the first guy here, what's our vertex? What's the coordinates of our vertex here? Okay, so this guy is 2. And how about the other guy? So here's x equals 2. And what's this guy? I think he's actually 3. Yeah. I know, these graphs are hard to read sometimes. Trust me, I do that kind of crap all the time. Don't worry about it. Okay, so then we said the way we write this is we say f of x equals, so we have x, and then we switch the sign on this guy, right? So it becomes x minus 2, right? And then the other guy, just leave him alone, plus 3. That's the equation of that parabola. Cool. So how about this guy? What's the vertex on this one? So we're going to go back 3. Okay, good. And how about the other guy? Yep, back 3, down 1. Perfect. And then to write the equation, we say f of x is going to equal x, switch the sign, plus 3 squared minus 1. That's your boy. So far, vertex form, not so bad, right? Okay, well, that's a good stopping point for today. We'll continue this discussion tomorrow. It's Thursday already. That's nice because you guys started on Tuesday, huh? All right. So I'll go ahead and shut down the recording. And I will thank you too for showing up. And we'll see you tomorrow, hopefully.